we are going to identify its bonds as ionic, polar covalent, or non-polar covalent. And if it's polar covalent, you have to assign a partial positive or partial negative on an appropriate atom. Okay, use the dipole moment arrow to show the direction of polarity. Okay. All right, that's first one. So, well, if you look at the electronegativity, so we got 3.5 and 2.5. The difference is 1. So that's a polar covalent bond. So that's about 0.5, right, between 0.5 to 2. So since this guy is a polar covalent bond, so oxygen who stronger will pull electron to itself. So it'll be, you get partial negative, carbon will get partial positive. The direction of polarity is going to go toward oxygen. Okay. All right. Next one, nitrogen and hydrogen, or totally. So 3 and 2.1, the difference is going to be 0.9. All right. So above 0.5 is a polar covalent bond. Nitrogen is going to win, right? So stronger, pull electron toward nitrogen. So delta negative, partial positive on hydrogen. The polarity go toward nitrogen. Here we go. All right, sodium chloride. So sodium chloride, sodium is 0.9, really low. Chlorine 3 is really, really high. The difference is 2.1 is above 2. This is an ionic bond. So we do, for ionic bond, one of them going to be cation, the other one going to be anion. We can't really use the partial positive, partial negative, because the charge is a real charge, not just a like half charge or partial charge. Okay. In this case, it's going to be positive and negative. All right. This is an ionic bond. Next one, all right, we have iron and chlorine. So iron is 1.8, chlorine is 3. The difference is 1.2. So this is a type of polar covalent bond. Really? It's something smelly here. Well, metal and non-metal. Remember when we talk about metal and non-metal, what type of bond is that? That's an ionic bond, right? But from the cutoff, from the electronegativity cutoff, this is a polar covalent bond. Well, what are we saying in this? Is it a polar covalent bond or ionic bond? Well, I'll say this. So there are many theory that talks about the polar covalent bond or ionic bond. The cutoff are different, right? So when you use all this theory, you have to use it loosely. In this case, the bond between iron and chlorine can be considered both. Sometimes sometimes you can consider it as a polar covalent bond. Other time it acts like an ionic bond. All right. If this bond were to act like an ionic bond, if you remember the normal oxidation number of iron is +3 and chloride is -1. Right? In those cases, this bond will act like an ionic bond. Does it make sense? Okay. So I mean, it's not really a real cutoff, and it's not a true cutoff that you can tell this is an ionic bond, this is a covalent bond. Everything is in spectrum, right? If it's ionic, it's gonna be how much ionic could be. It could be really, really ionic, or could be really low ionic, which is really close to the highest polar covalent bond a bond can be. So I mean, it's in a spectrum. All right. So in this case, it depends on the situation. Okay. So this bond of iron and chlorine can be both an ionic or covalent bond. Yeah, it could be either one, either or. But yeah, you're not gonna see this on the exam. Don't worry. And I'm not really gonna ask you about like something that ambiguous like this. Okay. So you're gonna see like the real one, like 1.9, 2, above 2. You're gonna see like this, like easy cut off there. All right, now last one, C and H. All right, so the difference in electronegativity is only 0.4. So this one is non-polar covalent bond, so below 0.5. Yeah. All right, one more time. So ranking the following bond with their polarity. Okay, so we have a rank of electronegativity rank right there. I'm going to teach you how to use it a bit later. But if you want to calculate it, so you can calculate it. All right, so oxygen and oxygen have the same strength, the same electronegativity, so no difference, so 0. This is a totally non-polar covalent bond. Chlorine and oxygen, right? Hydrogen and oxygen. So if you look at the electronegativity, you can look it up anywhere, right? The difference is 0.5, 1.4. So the bond polarity is going to be hydroxide, OH bond, ClO bond, and then OO bond. But sometimes you don't really have to do some calculation rates. If you look right here, all right? So oxygen and oxygen, totally the same strength. One of them pull to the left, the other one pull to the right. They have the same strength. So no difference in electronegativity, totally non-polar. But now these two bonds right here, well, they both got oxygen pulled to the right at the same strength. Now hydrogen and chlorine pull to the left, right? And you know hydrogen is the least electronegative atom among non-metal. Pull to the left with the weakest strength. Chlorine pull with a bit much better than hydrogen. So they cancel out that. The overall polarity, this guy gonna win. So oxygen gonna pull to the right much better, higher than OCl bond. Okay, so you can compare like that. So we go HO more polar than ClO and more polar than O and O. All right. Okay, now so this is the bond, the polarity of a bond. Now we're going to talk about the polarity of the inner molecule.